The point of this video is to show you how to find the equation of a tangent of any function. In this case, it's going to be a polynomial function of third degree. And we're going to show two ways of doing that. One analytically, two graphically, more specifically in Geogebra. Okay, let's go and have a look at the first way, which is going to be analytically. So here we have the question, find the equation of the tangent of the polynomial function x to the power of 3 minus 5x squared plus 2x plus 8. And the specific point is given, 1.6. For x is 1, y is 6. So this is quite important information over here. And we know that the equation of a tangent has the general form of y is equal to mx plus c. And this is the general equation of a straight line. In this case, for our tangent. Okay. Now we have learned previously that m is the slope or the gradient. And at that specific point, when x is equal to 1, the slope of the tangent is also the slope or the instantaneous rate of change of our polynomial function. And when I'm mentioning instantaneous rate of change, that means finding the derivative. The derivative gives us the gradient of the tangent at that specific point. So let's go and have a look. Let's go and find the derivative of our function. So that will be f prime of x is equal to 3x squared minus 10x plus 2. And this is the m. This is the gradient of our tangent at any point x. But since we know that we want that tangent to go through the point x is equal to 1, then we're going to sub in the value of 1 for x. So it's going to be 3 times 1 squared minus 10 times 1 plus 2. And that will give us 3 minus 10 plus 2, which will be equivalent to minus 7 plus 2, which is minus 5. So we know that m is 5. And we also know the point y and x or y, which is 1,6. So what's left to find is c. So let's solve it. Maybe I should change the color. So y is equal to mx plus c. Then y is going to be 6. M is minus 5 here. Sorry, I made a minor mistake. Minus 5. X is going to be 1 plus c. So c is going to be 6 plus 5. So c is 11. So m is negative 5. C is 11. Therefore, the equation of the tangent at 1,6 is y is equal to minus 5 x plus 11. So this is how to do these kind of questions analytically. And now we're going to see how it's done graphically using Geogebra. We have Geogebra where we're going to draw our polynomial function. And we're going to show how the tangent nicely move across this function and how its equation changes, and also the gradient of the tangent changes. So this is going to be a nice visualization of the function and the tangent. Let's go and have a look. So we're in Geogebra, and from these options we choose graphing. I am going to type my polynomial function, which is x to the power of 3 minus 5x squared plus 2x plus 8. And this is my beautiful function. Okay, so I can adjust this a little bit. I can change the color of this line just by clicking on it. Click on this, and then I would like to make it dark blue. Next, you could see how the graph of the derivative of this function, and that will be f prime of x, and that's how it looks like. If you don't want to see it, then you just click again on here. If you want to see it, you click it. If you don't, you click it again. Why not adding a slider to show us the x values? So from -5 to 5 with step of 0, 1. Great. There's our slider. And next we need to add the point. So it's going to be f of a as the point on our function, and that's where the tangent will be. So next we add tangent, point function, and the point is a, the function is f of x. And that is my tangent. You can see that we can move it as well across my function. And here, as I said before, here you see the x values. So if I have it here, that's when x is 0. Okay. I will change the color of this tangent. I'll make it red. There we go. And one more thing, I would also like to see, just by looking at this equation, you can see that the gradient is 2, but maybe you would like to see it separately. So I will have my function g of a, okay, and these numbers match. If you want to add this equation here on the coordinate plane, you can just drag it, and you'll see that it will change as we move the tangent. And I can also drag this, which is the gradient. Okay, and as I mentioned before, these numbers will change. Let's have a look. So I drag it along the function. Okay, so for example here, the equation of the tangent is -5x plus 11. So the gradient of the function, or the slope of the function, is -5. It's a negative. It's a negative slope, which also means that at this point here, where x is equal to 1, x is equal to 1, we can see it. The instantaneous rate of change of this polynomial function is -5, which is the same as the slope of the tangent. So the slope of the tangent when x is 1 shows you the slope of this polynomial function when x is equal to 1. And this is the equation of the tangent at this point when x is equal to 1, which is -5x plus 11. The slope is -5. Thank you.